Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate. If you'd like to join me live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 2 until 3 in the afternoon. And we are now in our 6th week of, no, we're not, we're in our 7th week of our 9-week course. So you definitely should know what to submit for marking at this point, but a reminder that the support questions are not for marking. They are practice problems to help you feel confident with the material. So you can decide which ones and how many to do. If you're understanding a concept, it is completely fine for you to skip questions. You don't have to do them all just because they're there. But if you need more practice problems, feel free to ask, and I'm happy to send you some. The answers are in the back of the booklets, so please check your work to make sure you're on the right track and to really set yourself up for success. The key questions, the ones with the little key icon, are the ones to submit for marking. So please do all of these, show all of your work, your steps, and your thinking. This way I can truly understand what it is that you understand. And if you're making any errors, it gives me more information to help you. So how do you submit your work for marking? There's 3 methods. The first is to scan your work and send it electronically. If you have a device, you can scan your completed work through the Notes app if you have an Apple device, or the Google Drive app if you have an Android device. These are applications that generally come free with these devices, though they are easy and free to download. If you're not sure how to use them, I have tech tutorials on my YouTube channel that walk you through for each individual app. So just go check those out on my page, and you can then send your stuff that way. Then once you have it scanned, to send it to me either through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger, where my name is B Slate Wahsa. Also, it's completely fine to take pictures. If you can't scan, that's totally fine if that works better for you. The second method is drop your work off in Sioux Lookout. We have an outdoor mailbox at our location 74 Front Street. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. So you can just put your work in there and we'll get it back to you as soon as possible. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732, or toll-free fax to 1-800-463-7852. Students can also fax their work in if you have access to a fax machine. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B Slate Wahsa. So you can friend me on Facebook and subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our videos. All of our radio Zoom classes are recorded, and I post them to YouTube shortly after airing. Also on YouTube, I have short videos that explain common errors and confusing concepts. In case you're struggling with something, there might be something there that can help you with sort of fundamental building blocks that aren't necessarily addressed in our course, but are skills that you do need and you might be struggling because they're very common areas that people struggle with. Math is a really visual subject, so I strongly encourage you to access the videos and not just listen to the audio. You're really not going to get the full experience unless you see the videos. So you can join me live, even if you don't want to talk to me, just pop in and watch. That's totally fine. Or you can watch the replays on YouTube. Then you can do it on your own time and pause and rewind if need be. If you don't have either of those options, you don't have reliable internet and that doesn't work for you, then let me know, and I'm happy to send you a copy of the recordings so that you get the full experience and set yourself up for success. If you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslate.wahsa. You can call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m., though I teach the last hour of my day, so that's not a great time to get a hold of me.
We are diving into lesson 17, which is measures of central tendency and standard deviation. We're going to be doing this lesson in two parts. So today we're going to be looking at measures of central tendency, and then in our next lesson, we're going to be looking at standard deviation and other measures of variation. All right, so our learning goals for this lesson are that you will be able to say, I will be able to distinguish between the mean, median, and mode averages. And 2, I will understand the purpose of the range, variance, and standard deviation for a set of data. The success criteria are that you can calculate the mean, median, and mode averages, and that you can calculate the range, variance, and standard deviation. All right, let's activate our brains with doing some mental math. We know that I'm not a fan of mad minutes. They were often stressful for many folks in elementary school and really set a negative tone towards math learning. And they didn't give us any tools. They didn't actually help us learn anything. So instead of doing that, we built strategies that you can do mental math to do arithmetic that are transferable and used in various situations. Question today is 720 divided by 36. And we're going to be using the strategy of proportional reasoning. So this is when we know that if we keep the proportion the same, the same number of groups is going to be true. So 720 divided by 36 are really big numbers. If we can find numbers that are similar or the same proportion, they're going to end up being the same answer overall. So I know that 720, well, I know that 72 is divisible by 12. So that leads me to believe that 720 is also going to be divisible by 12. 72 divided by 12 is 6. So that makes me believe that 720 divided by 12 is going to be 60. And so if I want to keep in the same proportion, I'm going to divide 36 by 12 as well to keep it in the same relationship. So 36 divided by 12 is 3. So I was able to make my groups a lot smaller in order to figure that out. So then here I can say, okay, well, 3 is a prime number. 3 is only divisible by 3. So, and 1, but that doesn't help us. So 60 divided by 3, I can think still in proportion if I wanted to. I can say, okay, we'll divide 60 by 3, and that's going to be 20. And divide by 3 is going to be 1. So 20 divided by 1 is 20. So these are all in the same proportion. I can pick different amounts to change my numbers in proportion, but I still end up, there's still the same relationship. So 720 divided by 36 is 20. And that's how we use proportional reasoning to do division. All right. Mine's on. Let's engage in some prior learning and get us set to do some more statistical analysis. So we need to have some definitions to make sure that we are all talking about the same things. So the first one is data point. So this is one piece of information. So for example, your math grade is 74%. That is one data point. A data set is a collection of information. So for example, all subject grades are 92%, 74%, 85%, and 71%. So the data set is that collection of all of your grades, whereas the data point is the individual pieces of information. Set notation is often used, and it's used, I believe, in your booklet. So this is a list of the information, and it's contained within curly brackets, which are also known as braces. And so here I have on the screen showing an opening of a curly bracket, 92, 74, 85, 71, and then a closing of a curly bracket. And that just shows us that that's our list of information. That's our data set. And it's how we write it out when we're doing it mathematically, opposed to listing it or within in context. So that's just important to know that I'm often going to be saying data point or data set. So it's important to know that data point is one piece of information and data set is the collection of information. And I'll be using set notation in your IEL booklet and in on the screen. So it's important to know that that's data set that's how it's listed with curly brackets. I'll probably call them curly brackets, maybe braces, but curly brackets is how I think of them. All right, so let's activate some new learning and explore these new concepts. So always answering the question, when will I use this in real life? So we are becoming comfortable with numbers in this course. So the reason for that is so that we can be informed members of our community, so that we can understand the numbers and the information around us and be able to make informed choices and decisions and be able to make have our own knowledge and know what we're doing with our lives. So it's really important to be able to be comfortable with numbers because they pop up all around us. So here's some examples of central tendencies in different ways around us. So I have a graph here, a histogram, that is showing the distribution of newborn weights. So you can see that it ranges from 6.7 to 8.5 in pounds. And then we can see this frequency. So clustered around the middle is where there's most babies are born that size. And then as we get to higher and lower extremes, they get lower and lower. Of course, there are babies who are born bigger than 8.5 and babies who are born smaller than 6.7, but this is the middle ground. Also, in terms of, we have a picture of advertising methods. So the frequency of, do we advertise in outdoor advertising, on digital advertising, printing advertising, or on our mobiles, on social media. So how we measure those things is also part of our central tendency, knowing which ones to choose to set yourself up. And then we also have a bar graph here that shows US household incomes. I just found a US list, so it's probably similar to in Canada, and shows that many folks, you can see on this graph, there's a lot of high frequency on the lower end of the spectrum in terms of earning from $1,000 up to $80,000 is where there's a bulk of a lot of the people are, and then a lot of the households, and then it decreases and decreases until there's some spikes at the end where there's a bunch of people who earn a lot of money of over $200,000. So that's just another way of showing information, and then analyzing this is what we would do with measures of central tendency, which is what we're going to look at today. All right, so let's dive into what that means. So this is on page 7 of your IEL booklet in Unit 4. So the measures of central tendency are a single value that attempts to describe a set of data by identifying the central position within that set of data. So that it's thought of as the middle or the average or the center of the data set. It's always between the highest and the lowest data point. And the most common types and the types that we're going to be talking about are the mean, median, and mode. So first we're going to look at mean. And again, this is on page 7 of your IEL book. So this is usually called the average, and it may be called the arithmetic mean. So often when people talk about averages, they are referring to calculating the mean. Technically, the mode and the median are also averages, but when people say, oh, your average is this, or the average in this situation is that, they're referring to the mean. So how it's calculated is that you're adding the total of all the data points and then dividing it by the total number of data points. So the mean is equal to the sum of data points divided by the number of data points. So let's look at an example of calculating the mean. Again, the mean is equal to the sum of the data points divided by the number of data points. So I have a collection of temperatures from mid-March and for a 2-week period. And so we're going to calculate what the mean of the mean temperature is. So I have a list of, I just screenshotted this from, I think, the Weather Network website. So we have negative 13 degrees. These are all in Celsius. Negative 12, negative 10, negative 8, negative 7, and negative 5, negative 2, 0, negative 6, negative 4, negative 3, negative 3, negative 3, negative 3. So that's our data set. So to calculate the mean, we're going to add together all of those data pieces. So that is our first step, is taking each of those data points and adding them together. Because a bunch of them are negative, we need to keep that in context. We need to remember that we have to add correctly with our negative values. And then we're going to divide by 14 because there are 14 data points. It's a 2-week image. So we are adding up 14 data points and then dividing by 14. So the mean is equal to negative 79 divided by 14, which is equal to negative 5.6. So the average temperature for those 2 weeks was negative 5.6 degrees Celsius. All right, if you want to check out the support questions on page 8, question 1 gives you some practice for calculating the mean. All right, so now we're going to look at median. Median is on page 8 of your IEL book, and the median is the middle value of an ordered set of data values. So if you have an odd number of data points, it is the middle value, it is the middle number. You have to order your data sets. So you rearrange them so that you're going from smallest to biggest, and the middle number is your median. However, if you have an even number of data points, that means there's no middle value. You're gonna end up with 2 numbers in the middle. So you add those 2 numbers together and divide by 2. So this finds the halfway point between those 2 middle points, and that is your median. So your median is defined by the middle value when your data is organized from the lowest to highest. You have to organize your data. It can't just be the way that the information is presented. So let's practice calculating the median. Again, your median is the middle value when the data is organized from lowest to highest. So taking the same temperature for those 2 periods in the middle of March. And the first step is to organize our data. So one way to do this is just start from one end and say, okay, negative 13, that is my lowest point. So I'm going to write down negative 13, and then negative 12, then negative 10, negative 8, negative 7. But then when I'm following along, I see, okay, well, now I have negative 6 is lower than negative 5, which was the one that was just written after negative 7. So I write down negative 6 and then go back to negative 5. And then I have to look for what's the next lowest one, or the next one in the sequence would be negative 4. And then negative 3, negative 3, negative 3, negative 3, and then negative 2 and 0. So you have to be very careful about paying attention to what your values are and organizing them from lowest to highest, especially when you're dealing with negative numbers as well, and remembering that a higher value of a negative number is a lower number. So that negative 13 is lower than negative 7 because it's more cold. So that's step 1, is to organize them. And then step 2 is to cancel them off. And so how I do that is to figure out what the middle value is I look and I say, okay, I'm going to cancel. I'm just going to cross off my lowest value and my highest value. And then I'm going to do my next lowest value and my next highest value. And I do this in pairs, so that I cancel off these values back and forth, going from lowest to highest, to figure out what my middle value is. In this case, we have 2 middle points because we had 14 data points, right? We had an even number of data points. So we're going to end up with 2 in the middle. And so what we do is we add those 2 together. So negative 5 and negative 4, we add together and we divide that by 2 because there's the 2 points. And we're finding what the halfway point is between those 2 ones. And so negative 4.5 is the median, is the halfway point between those 2 middle values. Again, if there was only one middle value, if we cancel off back and forth and end up with just one number, then that would be your median. Great, so then if you want to pause the video and do support questions on page 9, question 2, those are some practice for calculating median. And then finally, the mode, which is on page 9 of your IL book. So the mode is the data point that occurs most often. It's the most frequent. So what if there are 2 data points that have the same frequency? Then you have 2 modes. So you can have multiple modes if they all have the same frequency that is the most. So the mode, again, is the most frequent data points or point. All right, so calculating the mode. So it's the most frequent data points. So again, looking at our temperature from mid-March, it can be really helpful to organize your information again so that you don't miss anyone. So because if you're going to collect the numbers that are the same, if you do that, if you organize them, then you're not going to miss any. So you don't have to do this. You can just look at your data and say, oh, this is what I can see is happening the most often, but organizing it can also be useful. So another way of organizing it is to just list your numbers and then like check them off instead of drawing arrows. It can be a little bit cleaner. So we have -13, -12, -10, -8, -7, again, -6 we have to pay attention to, then back to -5, then -4, then -3, -3, -3, -3, and then -2 and 0. So then for the second step is you're going to list the frequency of each of those data points. So -13, I only have one -13. Because I've ordered my data points, it's easy for me to see that I only have one, but you could also do that just from your initial data collection. So -12 is also only one, -10 is only one, -8, -7, -6, -5, -4, they're all only one. Then we get to -3, and we can see that we have 4 of those values, and then -2 and 0 are also 1. So you can see this is real data. I didn't create this. I just took a screenshot of the actual temperatures, and we can see that we have one mode because -3 is the most frequent. It occurs 4 times, whereas everything else just occurs once in that 2-week period. So that's how you find mode, is that you just need to find the most frequent. It's usually the one that people find the simplest because you're just really just counting points. You don't have to do any calculation. So on page 10, you can now do questions 3 and 4. I believe question 3 is practicing mode, and then question 4 is doing all 3, the mean, median, and mode, figuring them all out for the same data sets. All right, but then the important question is, well, which average is the best? Why do we have multiple averages? And when do I use them? So it really depends on the situation. We can't say that this is the best one all of the time. It depends on what the data set is, what you're trying to find, what type of data you're dealing with. So you have to know your situation in order to figure out which one is the best. You need to be wary of the use of the word average because information can be accurate yet misleading. So often in media or in the news, they might say, or in reports, they might say, well, this is the average. And you may make an assumption of what that means, but they might mean something else, but it's still technically accurate. They're not lying. They're just using language in sort of a evasive way that can be confusing. So you just need to be conscious of that. So at this 2-week period in March, so if we answer the question, what is the average temperature in mid-March in Sioux Lookout, which is where these temperatures were. So again, I'm showing you the 2 weeks of temperatures, and the mean was -5.6 degrees. The median was -4.5 degrees, and the mode was -3 degrees. So these are all averages. I could say, depending on what I wanted to convey, what information I wanted to convey, if I wanted to say, well, it's still really cold in mid-March, I could say that, well, our average temperatures are -5.6 degrees, whereas some places in Ontario, they're in the positive. So that could say that would be true. That is the truth, is that the average is -5.6. But if I wanted to say, if I wanted to convince myself that spring is coming, and I could say, the average is -3, like we're getting super warm, it's almost above 0. I could say that the average temperature for those 2 weeks in mid-March was -3, and that still would be true, but it would just be some different information. So you have to be conscious of the fact that this is all true, but slightly different depending on the way that I collected that information. So it's important to be really honest about that, and then just recognize that when you are interpreting information. So again, which average is best? So let's look at different situations and see when each would be best. So the mean is the most frequently used. The mean average is what most people use when they're talking about average. And it's the most accurate when data is continuous and symmetrical. So if the majority of your information is gathered in the middle, then your mean is going to be an accurate representation of your average. So here is a diagram where you can see it. We have a salary distribution. And so the mean salary, which would be, say, roughly, I don't know, $64,000, looks like it's the middle of the people who are earning money wherever this is. So we can see that there are definitely people who earn a lot less than that, and definitely people who earn a lot more than that, but it's clustered around the middle of that middle value. And so the mean is going to be an accurate way to represent that information. The median is best used when data is skewed left or right. So, or when there are outliers present. So when it's not clustered in that same way around the middle values, the median is a better choice to choose. So here I have a diagram of the square footage of homes, and you can see that we have an outlier where we have this one set of frequencies that are up at 7,000, whereas most of the other ones are down between 1,400 and 2,800. So this information is really, this outlier is really skewing your mean. It makes your mean seem a lot higher when really the majority of the houses, the square footage of the houses is actually lower than that. The middle point is actually much lower. So the median would be a better representation because that's going to give you the middle value. And these high frequencies are only going to count a little bit instead of the mean where they pull that information up. Then finally, the mode is best used for nominal data because the categories cannot be in any meaningful way. So nominal means the name. So if they don't have a number value, then the mode is the best way because you can't actually order it. There's no higher or lower. So I have a graph here that's showing transportation and the number of students who take that transportation. So if you're asking on average, what transportation method do students use, then using the mode makes the most sense because you can't actually there's no weight in terms of which one is better or worse. We just organize them, and the car you can see has the most frequent use. And so that would be the mode, which makes the most sense in this way because we can't organize the information in any other way. All right, so let's consolidate those things again and then do some practice questions. So this is again from lesson 17, and we are just doing the measures of central tendency. The standard deviation part we will do in our next lesson. So the mean, we add up all the data points and we divide by the total number of data points. The median, we order our data points from lowest to highest and find the middle value. If there are two middle values, then we add them up and divide by 2. And the mode, when we order the data points from lowest to highest, if that's relevant, and we find the value that has the most frequent numbers. So it's possible to have more than one mode if they have the same frequency. And so our success criteria is that you can calculate the mean, median, and mode averages. So knowing those 3 differences, when it's best to use them, and to actually be able to calculate them. All right, let's do some problems. So number 1, Gabriel buys 8 DVDs at Discount Dan's DVD shop. 3 cost $10.50, 2 cost $7.75, and 1 cost $5.25, and 2 cost $3.50. Find the mean, median, and mode of the cost of his DVDs. So we're going to start with finding the mean. And we do that by adding up all of our values. So with this one, we have to be careful because we have to know how many we have of each of those. So we have 3 that cost $10.50. So we have $10.50 plus 1050 plus 1050 plus 2 that costs 775. So plus 775 plus 775 plus 1 that costs 525, 2 that costs 350. All of that is divided by to figure out how many we have. So we can just count 1, 2, 3, 4, 5, 6, 7, 8. So we have divided by 8. So then using Desmos or your own calculator, percent. So we have 10, 50 plus 10, 50 plus 10, 50 plus 7.75 plus 7.75 plus 525 plus 350 plus 350. If you wanted to use multiplication instead of writing them all out and doing the addition, that is fine. If that makes sense to you, it's fine. But if you want to write them all out, that works too. So then the total is 59.25. So then 59.25 is how much we added them up. So then divide by 8. 59.25 divided by 8 gives us 7.406, so $7.41. So the mean of the cost of DVDs was $7.41. So then the median, we need to order them from lowest to highest and then find the middle value. So we have 3.350, 350, we had 2 of those, and then 525, 775, and then 775, and then 1050, and then 1050, and then 1050. So then we're going to find our middle value. So how I like to do that is I'm going to cross off my lowest and my highest, and then my next lowest, and my next highest, and then my next lowest, and my next highest. And I see that my 2 middle values are 775. Well, because they're the same value, I can tell, well, if I add them up and divide by 2, I'm still going to end up with 775. So I can just tell that my median is 775 because my middle values, the 2 values are the same. So if I add them together and divide by 2, I'm still going to get 775. And so that's what my median is. So then my mode is my most frequent value. So we know that they have 3 that cost 1050. And so that's my most frequent number. So 1050 would be my mode. So you can see those values can be really different depending on the data points. So that's why it's really important to know which one is best to use in the situation. Okay. All right, number 2, the prizes in the local lottery are worth the following: 2 prizes of $1 million, 7 prizes of $350,000, and 10 prizes of $250. So how should they advertise their average winnings is what the question asks. So we're trying to find the average. Which one is going to be best? Is it going to be best to say the mean, median, or the mode? So the mode, we can tell right off the bat. We don't have to do them in the way that we've done them before. The mode is $250. That is the most frequent prize that you could win. So that would be one option. That would tell us a very low average of winning, which generally isn't our goal. It's not going to encourage people to buy tickets if they think they can just win $250, but they could potentially earn $1 million or win, not earn. So then the median, organize our information. So we have 10 250s. So 250, 250, 250, 250, 3, 5, 6, 7, 8, 9, 10. You don't have to write them all out if you don't want to. If you think that you have a way that will be easier, it's your call. So then you just need to make sure that it's organized. So then 350,000. What's the zero off there? So we have 7 of those, 350,000. So that's 2, 350,000. That's 3, 350,000. That's 4, 350,000. That's 5, 350,000. That's 6, and 350,000. That is 7. And then 2 instances of 1 million. So as you can see, I wasn't able to write this all out in one straight line, but I have them ordered, so I can still cross off my lowest one and my highest one. And I just go back and forth and cross off my lowest one and my highest one, my lowest one, my highest one, until I get down to the middle. Again, there are other ways to do this. You do what makes the most sense for you. And so here, our median is also $250 because that is the middle value. So right now it's looking like it makes sense to say $250. Our mode and our median are both saying that $250 is the most frequent thing that happens. So then let's look at the mean. So before we listed them all out and added them up, we could do that. We could just do that. I'm also a shorthand to do that is that I know I have 10 instances of 250. So I'm going to do 10 times that plus, then I know 7 instances of 350,000. So I'm going to do 7 times that and then plus 2 times 1 million. So this just is a shorthand of writing the same thing. It's instead of writing them all out, I can just do this multiplication and it's going to be the same because if I add 250 10 times, it's the same as doing 10 times that amount. And then to figure out how many we need to divide, well, 2 plus 7 is 9, plus 10 is 19. So we have a total of 19 prizes. So then to do that on Desmos, so we have 10 times 250 7 times 350,000. Make sure you get enough zeros, plus 2 times 1 million equals 2,652,500. I'm just going to divide that by 19. Instead of writing it down, you can write it down if you wanted to. If you're feeling lazy like I am, you can just write it. You can just do the division. So then the mean is $139,605.26. 139,605.26. So I just have to remember it. 139,605.26. Just gonna check to make sure I did that right. Yeah. So the mean says that the average winnings are $139,605.26. Now, if you want people to be buying your tickets, which way are you going to say that you want them, that the average winnings are $250 or the average winnings is $139,605.26? I think that they should advertise using the mean because it's the highest value. If you disagree with me, that's fine. You just have to have a reason why. If you want to say that because the mode and the median were both 250, so that feels more accurate, then you could say that. But I guess it depends on what your goal is in terms of accuracy, in terms of what is the most appealing to buy tickets, or if you win more money or less money. But this is how the lottery actually works. Well, they say you could win this, but it's much more likely that you won't. All right, number 3. Find the mean and median for each set of marks for Susie and Roots. So Susie so they each have 6 marks. So for Susie, mean first. And so we have 25 plus 36 plus 39 plus 87 plus 89 plus 94 divided by 6 is the mean. In your calculator. So 25, 36 plus 39 plus 87 plus 89 plus 94 is equal to 370 divided by 6. Is equal to 61.66, so 62% is the mean mark for Susie. For the median, I'm not gonna, they're already organized from highest to lowest, so I'm just gonna say, okay, 25 and 94, 36, 89, cross those off, and then we get, so 39 plus 87 divided by 2 to find the median. So 39 plus 87. Sorry, my computer is not liking me. Divided by 2 is equal to 63. Okay, so then the other student Roots. So the mean is 45 plus 56 plus 88 plus 89 plus 92 plus 98, all divided by 6, because there's still 6 marks. Use our calculator. So we have 45 plus 56 plus 88 plus 89 plus 92 plus 98 is equal to 468 divided by 6 gives us 78. So 78 is our mean, and our median. So again, they're already organized. So crossing off till we get to the middle values, we have 88 plus 89 divided by 2. I can tell that that's just going to be 88.5. So then question B says, what is the best measure of central tendency for Susie, the mean or the median? Well, the median is 63 and the mean is 62. So the median gives a higher average. That's our goal. Then C, what is the best measure of central tendency for Ruth, the mean or the median? So again, the mean for Ruth is 78 and the median is 88.5. So again, the median is that gives a higher average, which is what we're assuming is what they want. So there we go. All right, and number 4, find the mean, median, and mode for each set of data. We just have a list of data. This is what your questions are very like in your booklet. So the mean, instead of writing them all out, I'm just going to add them up for the sake of time. So you can do that. However, if you do make the choice to just add them up and not show your work, then it means that if you make a mistake, I don't know where you made the mistake. So 64 plus 69 plus 72 plus 54 plus 89 plus 92 plus 54 plus 32 equals 476 divided by, looks like 1, 2, 3, 4, 5, 6, 7, 8. 476 divided by 8 is equal to 59.5. So the mean is 59.5. Right, and then the median is equal to, well, we have to look, and the numbers are not organized, so we need to organize them. So we have 32. Slowest one is 54. And there's another 54. Lowest value is 64, 69, and then 72, and 89, and then 92. So then cancel them off, the lower and the higher, to get to your middle values. I seem to be constantly having even numbers. That was not intentional. So to find our median, we need to do 64 plus 69 divided by 2, which is equal to 66.5. And then our mode for this value, for this data set, well, we can see that we have 2 54s, so 54 would be our mode. And that's the mean, median, mode for that data set. All right, one last one. It has more values. Again, I'm not going to write out all of the numbers. I'm just going to put them on my calculator just for the sake of time. So we have 0 plus 2.1 plus 5.7 plus 8.3. But as you can see, I just made a mistake, and if I wasn't paying attention and I didn't catch it because I didn't write it down, I wouldn't know why I made that mistake. My calculator doesn't like it today. 2.6 plus 7.3 plus 8.4 plus 0.5 plus 0.4 plus, what's my last values 2.1 plus 2.2 plus 4 plus 5.7 equals 49.6. How many points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 49.6 divided by 13 is equal to 3.8. So the mean is equal to 3.8. Median. So this time we are going to have to write them out so that we are in the right order. So we have 0. And then our next lowest value we have to find, which is 0.4. We have 0.5. Lowest value, we don't have any 1 point anything, so we have 2 point. Another 2.1. 2.2. I have 2.6. So really just need to figure out what works best for you in terms of organizing your data. Then we have 5.7. 5.7. I missed 4.3. It's really easy to do that. So just got to be careful. That's why writing your information out is good so that you can see. So I missed a 4.3, 2 5.7s, 7.3, 8.3, and 8.4. So then I'm going to cancel them off to figure out what's my lowest and highest. And that just goes back and forth. Again, you can do it a different way. If a different way makes sense to you, this is what makes most sense to me. Find that we have 2.6 is our middle value. We only have 1 this time. So our median is 2.6. And our mode, I'm not going to write them all out again, but we can see, because we ordered them, we can see we have 2 2.1s and we have 2 5.7s. So the mode has 2, 2.1, and 5.7 are both the modes. That's how you would do that. So it's really repetitive, but you just need to really make sure that you're paying attention to detail and you're not missing things, because as you can see, super easy to happen. All right, so lesson 17 from your IL booklet is going to be continued in our next class, where we're going to look at the other parts.
If you have any questions, please feel free to reach out. As always, you can call me at the office at 807-737-1488, extension 2209. Feel free to leave me a message and I'll get back to you as soon as I can. You can also call toll free at 1-800-667-3703. Send me an email. My email address is bronwyn.slate, and that's spelled BRONWYN.SLATE@nnec.on.ca. If you want to connect with me through Facebook, my profile is called B Slate Wahsa, and my YouTube channel is also B Slate Wahsa. Remember, all of our lessons are uploaded there after they air in a playlist called MBF3C. So check it out so that you can go through any information, either this one or previous lessons as needed. My office hours are Monday through Friday at 9 a.m. to 3 p.m. Except on Thursdays, I'm actually in from 10:15 to 4:15. So please reach out and connect with me whenever works best for you. If there's a time, if our times don't line up, let me know, leave me a message, send me an email, and we can try to arrange a time that works for both of us if my office hours don't work for you. Thank you so much for joining me today. I hope you have a lovely day. Miigwech.